The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
In the next set of demonstrations, we're going to illustrate some of the very classic phenomena associated with the diffraction of light. I hope that there will be educational, but also a lot of fun to see these effects. We'll start first with the Fraunhofer diffraction, both in one dimension and two dimensions, and then we'll go to Fresnel diffraction. So let's start first with Fraunhofer diffraction associated with a single slit. The setup is over here. We have a helium-neon laser, and here is the beam from the laser. We're reflected by this mirror here, and then we're reflected again by this mirror here onto the slit. This slit is an adjustable slit. By turning this knob here, I can adjust the slit. But in order to see that indeed this is a slit, I'm going to put a screen over here so that when I adjust the jaws of the slit here, you can see that indeed I am varying the spacing between the jaws. Of course, when it gets very small, it's difficult to see. So here's our adjustable slit, and here's the laser beam going through the slit, and then the diffracted light then falls on the screen over there, which is about 200 centimeters from the slit. So now we're ready to look at the diffraction pattern. So if we have a close-up then of the screen, we see the diffraction pattern for the slit separation that I have over here. Now, the wavelength of the light is that of the helium-neon laser, 6328 angstroms. So I gave you the separation between the slit and the screen, which is 200 centimeters. So now you should be able to calculate the slit width from the diffraction pattern. Now, to help you do this calculation, we have on the screen, we have markers, and the separation between these markers is 5 centimeters. So there are 5 centimeter markers on the screen. So now you have all the tools to calculate the slit width as I adjust the slit separation. So let me start with very narrow slit where the central lobe is, I can make it almost 5 centimeters or so, and you can see the other lobes, the weaker one. And maybe if we can overexpose a little bit, we can see that indeed there are there's lots of lobes. But if we expose for all of them, then the central one is going to get way overexposed. So in general, we'll be looking just at a few of them. All right, so now let's go back to where we were before, and then we'll start again at a slit width so that the central lobe is about a few centimeters wide, and then I will now make the spacing, I'll make the spacing wider, and you can see the central lobe now will get smaller and smaller. Now you can even see the spacing between the jaws, and here we are. You see, it gets intensity so high in the central lobe that we're saturating. But I think this is a pretty good illustration of the Fraunhofer diffraction pattern of a single slit. Now that we've seen the Fraunhofer diffraction pattern associated with a single slit, now we're going to make life a little bit more complicated. We're going to look at the diffraction pattern of two slits.